Hi, for all, I'm going to explain binary search with algorithm. Binary search with algorithm. Binary search with algorithm. Let's why we using binary search. When we finding a number in a sorted array, we want to consider half of the array and finding out. That example, we have an array, we finding out it. How? Why we finding? When example, phone contact, when I search Rahul, when I search Rahul, it not search from A to B, A to Z, like linear search. Yes, linear search. Here, linear search. Linear search nothing but checking elements one by one. Please students, my explanation is slow, that is helps to understand slowly. There is no fastness, because understanding slowly improve your fastness. So that why I am explaining slowly to you, because I want to understand to you. I want to that you understand perfectly. Whenever it slowly, even also it's okay, no problem. I use only simple English. This is linear search then. So whenever in phone contact, when I search Rahul, it not suggestions it's not shows from A to B Z, because it's took time to find R elements which starting with R, which name starting with R. So it's divide the elements. Let's A, B, C, D, E, so on, R, so on, Z. When it's divides two halves, this is one half, this is one half, and here E is greater than or less than R. It's less than R in order. When we assume E less than R, so cut this array, totally delete this array. This half won't consider then. When we consider this, and E to Z, it is low value, it is high value. When we find out mid, it's luckily R, then R is our results. So it's Rahul. It shows that Rahul. Okay, we knowing why binary search using in tech field. Because students, you have to understand, computer doesn't think and doesn't imagine what they are, how they are, elements are there, it is greater than, it is or less than, there is don't know, because they have don't know mind. We are build them, they don't think, we build them like to process. The computer main thing is processing. Computer equals to process information, because computer don't understand human language, so it wants this type of algorithm to proceed. Because humans have eyes, nose, brain, but system or computer doesn't have it, so it's going with algorithms, with a strategy, how the data processing. This is your main understandable basic ideal thing you understand in IT or CS or other specialization. By the way, I am also came from CSE and AML specialization. So let's get into the topic. We know why binary search using in tech field. So here let me take a practical example. Example 3, 5, 9, 12, 15, 17, 25. Let's find 17. This is the question. We know 0, 1, 2, 3, 4, 5, 6. In computer, the computer understand this array style, but we understand, we assume in the situation the computer understand this type, array type, but we assume, human assume, like human assume 1, 2, 3, 4, 5, 6, 7. Here n equals to 7, because the natural numbers, human every time assume natural numbers, that's likely 1, 2, 3, 4, 5, so on to n elements, like 1, 2, 3, 4, so on n. There is infinity numbers, but we have a finite number. The array is always finite number. In usually, mostly the array has finite numbers. Here n equals to 7. We know we consider the lowest index equals to 0 and highest index equals to n minus 1. This is the highest index. We assume here L equals to 0 and H equals to n minus 1, that is 6 minus 1, 7 minus 1 equals to 6. So this is L with 0 index. this is L 0 index, H equals to 6 index. This is the final index, this is starting index. We assume this is low, this is high. Let's find out mid. What is mid index? What is mid index? How to find mid index? Because mid index is a half of, it is the middle of the array. Let's find out. L plus H by 2 equals to 0 plus 6 by 2, because the lowest element is 3, but array name is assumed from array is 0, is an index value, is an index name value, I think. Okay, is equals to 6 by 2 floor. We get 3. So where is 3? Let's assume computer let's computer gets 3, then computer how assume this algorithm. It's assume 0 2 0 1 2 3. So here the computer find out here 3. So mid equals to 3. See, the array equals to A. Here A mid equals to 3. Let's check the A mid less than 17, right? This is our data. You can call it data. It's less than. If mid value less than our data, so mid plus 1 equals to L. So here our mid value is 3 plus 1 4. So mid equals to 4. Sorry, mid plus 1 equals to L. So mid equals to 4 plus 1 equals to L. 5 equals to L, and H equals to H as it is. So we get L equals to 5 and H equals to 0. Okay. 4 kada? Yes, we got 4. We got 4. Then our array is likely 4 5 6. So 15 17 25. 15 17 25. Then here L equals to 4 and H equals to 6. Let's find out mid value. Here L, here H. Floor equals to L plus H by 2. 4 plus 6 by 2 equals to 10 by 2 floor 5. Then our mid value is mid of A equals to 5. Then forgot delete this array because it's not considered, because well less than, so these all the less than values. So the 17 has only this array because it's less than 17, so it's considered only right of the array. So our mid value is 5. So let's compare. We finding 17. So a of 5 equals to 17. Here a of 5 equals to data 17 equals to 17. So it's founded. Here there are 3 circumstances. That one, mid value greater than data, so mid minus 1 equals to h, because I will show how it works. There is a array. Here the mid value greater than data, so the highest, we consider this pattern, we consider this array. So we start from 0, 2, 3, 4. So the L is the low array index is as it is, but the height is want to come to this side. So we consider this. As usual, the h previously stayed at this position, but whenever we assume the h is in this position, so the entire thing is deleted. And second situation, mid less than data. In this situation the mid plus equals to L. How it works? Let's assume 0, 1, 2, 3, 4. Here's the mid value. Here the L, here the previous H, previous L. So we have to consider this. We don't consider this, delete this, because mid less than data, so we have to consider this. So mid plus 1 equals to L. Mid plus 1 equals to L. H is as it is there, that place, but L is increment, because L is increment with mid, that is equals to L. So we are deleting this type and this type. So we consider in the right half. Here we consider the left half. There is one more circumstances, that is mid equals to data. Here we founded the data like this, mid, and the situation like L, H. If if mit equals to L equals to H equals to data, then we founded the data. This is the overall view. Let's understand the algorithm pseudocode. Pseudocode for binary search. Here, binary search of A n comma mit. Let rho equals to 0, h equals to n minus 1, while 2 L less than or equal to h, because L is always less than or equal to h, because it is array, because it is the last and it is the first. It is less than h, L less than h, because we see it is array. This array is number of elements. Mit array number. Mit array number. So here the L means here the L, here the H, here the mit. Assume like that. So find out how to find out mit equals to L plus H by 2. This is the mit value. So if or A mit greater than data, this data means which number we going to find it. So if mit value greater than data, A of mit greater than data, so mit minus 1 equals to h, else if else A mit less than data, so mit plus 1 equals to L, else A mit equals to data, that is return mit. We founded the data here. Let me explain. Mit formula, it is mit formula like this, L plus 1 by 2. This is whenever it is mit greater than data, like this, we consider in the left left side, like considered in the left side. This is H, this is L. We deleting this whole here when this meet greater than data, because the data, the value of data we are finding, this is less than. So here mid value less than data, so it is must be greater than data, greater than mid value. So we are deleting this and increasing the low from mid, that is H2 mid. Then this happens, this condition, if a of mid equals to data, that would be, this is mid, this is L also, and this is H also. We are deleting this all. We found it, that means we found it the required data. This is the algorithm for understand the binary search. Let me explain time complexities. It is the best case is equals to order of 1, because whenever we finding a data, what it would be like when we finding this is the mid value, this is our data, accidentally this is our required data accidentally, then mid equals to data, this is the best case. It happens the best case. What is the average case? Average case, let take the same example. This is a mid, we don't find it, we didn't find it, and this is the mid, we find it the second time, the second comparison, the second phase, I think. So H, L, this is mid, this is the average case, that is order of log n. First case also order of log n. We take this example again. This is H, this is L, and this is mid here also, and here. This is the worst case, because we use it all steps. We use it all steps. So this is the worst case. The worst case is nothing but we use it all steps. Space complexity of binary search, that is order of 1, because it stores like that. Whenever we storing, the mid value is only one element. Whenever we want to compare, the mid value is only one element, so space complexity is one element. So here, how to find out the maximum spaces? Let me give you an example that there are 8 elements: 1, 7, 6, 5, 4, 3, 2, 1. So we want to go from half, 4 elements, then 2 elements, then 1 element. There are 3 steps: 1, 2. There are 3 steps. These arrows, there are 3 steps. When this, we have to compare with data. So this is 1. The mid value compare to data. So 3 steps plus 1 step equals to 4. Here this written as log 2 8 equals to 3, because log 2 into 2 into 2 is equals to 3, because 3 times this overall value is 8. These into integer is base 2, so this consider this all producting integers we consider base, so the value is 8 equals to 3. This is how you understand the algorithm. So this is 3 plus 1 equals to 4. Here, this is how you solve in exams. Let me explain. Let an array contains 244 elements. Using binary search, what is the maximum number of comparisons required to find an element? Its main worst case, because how many maximum number of comparisons means worst case. So here option A 9, option B 10, option C 11, option B 1024. For binary search, we have worst case order of log n. So log n plus 1, because we want to compare mid value equals to data final This is halving and deleting left or right array. Previously we watched how it works. Let login plus 1, so log 20242 equals to 10 plus 1 equals to 11. 10 plus 1 equals to 11, so our answer is 11. Why we took like this? Because log 10 into 10 into 10 into 10, 2 into 2 sorry 2 into 2 into 2 into 2 into 2 into 2 into 1 2 into equals to 10. So we also write 2022 solve halving, then halving the array plus 1 when comparing to mid value of array equals to data. So we got 10 plus 1 equals to 11, so your answer is 11. There is 11 is answer.